that doesn't have time in it. Let's see, time. Let me do this. I know that average velocity is x over t. And I also know that b equals b naught plus at. Okay, I just learned that. So, let's see. What could I do? How could I get rid of t? In these two equations. Kind of. Yeah. And by the way, they're both representing the same t. So what I'm saying is this t and this t are the same t. They're describing them in two different equations. Yeah. No. So change our b's. I like your thinking. That's kind of something. We're going to do this like all semester, and there's different ways we can do it, and that would be one way. Yep. Oh, you're saying, are you saying isolate t here? Okay, let's do that. Get t by itself, so that is t equals x over average velocity, right? Let's do the same thing over here. Get t by itself. First up, actually, first I have two terms, so I want to get the terms separated first. So I would get this term and subtract it from both sides. So I got b minus b naught equals at. Then I would get divided by a. So I've got t equals b minus b naught over a, and t equals x over average velocity. Well, Ms. Rose, what the heck are you doing? I'm just trying to find an equation that doesn't have t. You can't see something, which is part of what Jim was saying too. Go ahead.
You can substitute equations for t.
Put them together. Is that where you're going to? Is that what you're going to say? Just put them together. If t equals this and t equals this, then set them equal to each other and forget the t. T's not needed anymore. So that's what we do. We say x over average velocity equals b minus b naught over a. Is that kind of what you were saying too?
Well, I was going to say
because I think what you were saying is we could substitute a whole nother equation in for t, which is something we will do during the semester for another situation. All right, so now, one thing I don't like here. I got my x, I got my a, I got my b and b naught. I got this average velocity business in here. And what is average velocity really? There's another way to write it. Renee? Over 2, based on how many things we added. Just average. If there's 3 velocities, we divide by 3. Okay? This is a typical way. And the reason I like this method is, or this version, is look, we have a b and a b naught, and a b and a b naught. They will probably stick if we put them together. Let's find out what happens. Let's substitute this in for average. Get rid of the average, get rid of the bar, and let's put what it really is. So that becomes x over b naught plus b over 2, fraction in the denominator, and then equals b naught minus b, b minus b naught over a. Now, there's probably a cleaner way to write this. Yeah, 2x over b naught plus b. You guys understand, if I have 1 over a half, what's that equal? 2 equals to 2. So you can just flip that over. 1 over a third. 3. You just flip it over. So this is 2x over b naught plus b. Just makes it a little plainer. Equals b minus b naught over a. Read that. That was b naught plus b. Okay, cross multiply. Cross multiply. So we get 2xa equals, what do we do with this? FOIL. Absolutely. B naught plus b. B naught plus b and b minus b naught. Okay. So we're going to just do a little foiling. You guys learn no big deal. Spin the page. And we're going to say 2xa equals first v naught times v outside. Positive or negative? Negative v naught squared. Inside. Positive v squared. Last. Minus v naught. Or v naught v. V naught, v naught. These are the same. So, plus and minus. This go away. See that? Now, we get 2xa equals negative v naught squared plus v squared. Well, I don't like negatives. Let's just bring it over. Clean it up. That gives me v naught squared plus 2xa equals v squared. How would a physicist write this? The unknown first, and then the v naught squared, and then put them in alphabetical order. 2a and x. Here's our third equation. And what was it missing again? Yep, no time in this problem. No, just no time. Oh. I thought you meant time not. Yep. On a quiz or test, when you're taking a test, I'm going to give you an equation sheet with all the equations. See, first of all, you don't have to memorize them. You are accountable for the derivations of the first two, but there's not a certain form. I'm going to give you, I think, I wasn't sure what you guys can do. I'm going to give you this equation, and then you have to use it. So, that's not what you asked. Go ahead, what were you asking? What two formulas? Oh, yeah. It's fine. I'm going to give you this one, but if you, like, set it up, when you're showing me your work, you set it different. They mean the same thing. Mm-hmm. Here's another way of doing that. All right, somebody made 80. Here's three of your quizzes: 82, 87, and 49. You know how to do that. So add 1, 2, and 3 together, and got 3. It's the exact same. Add a v naught, add a v, and maybe I have 12 more v's on top of it. I don't know about these. But the simplest form is just first and last about 2. Now, how accurate is that? Average velocity that way may not be that accurate. It depends. Yeah, average velocity itself. So, calculus is trying to find ways to find instantaneous. There's ways to try to find instantaneous. Okay, let's. What are we missing now? We need one more equation. Let's just go to the next page. All right, we need one that has no acceleration in it. Okay, that's kind of easy. Here's our average again. And here's our average. Here's two averages. Just put them together. That's it. Simple as that. Put them together. We're going to have our v naught. We're going to have our v. We're going to have our x. We're going to have our t. Everything but a. Just put them together. So if v equals this, if average velocity equals this, and average velocity equals this, then therefore x over t must equal v naught plus v over 2. Cross multiply, 2x equals v naught t plus vt. Well, I want to factor that t out that I just distributed. I guess I shouldn't have distributed in the first place, but I don't know if it was easy for you to see that or not. So I'm going to go 2x equals t v naught plus v. And let's get x by itself. That's how you'll typically see it in a textbook, is solve for x, but you don't have to solve for x. And that's the same thing as saying 1/2 t. Having 2 there just means 1/2 v naught plus v. There's our last equation. Boom, 4 equations. 4 powerful equations that allow you to make any prediction. And these are great, these are heavy. I mean, guys, you can pick girls up with these equations. You could, like, x equals b naught t plus 1/2 at squared. If a is gravity, and you know what gravity is, 9.8 meters per second squared, round it to 10, make it easy. Throw a rock off a cliff, count how many seconds it takes to hit the ground, you can tell exactly how high it is. She'll be like, oh, great. It is great. Oh my God. Girls all know what you can do with it. That's what we do. That's what guys do. Okay. Some of the guys are like, that's not what I do. Alright, so that leaves us with this. We've got x equals b naught t plus 1/2 at squared. We have v equals b naught plus at. Our third one was v squared equals b naught squared plus 2ax. Our fourth one was x, because I use them so much. 1/2 t v naught plus v. Now, what are they each missing? This one's missing. I forgot. Final. This is now, the reason I show what's missing is a lot of students actually find that more useful. When you're trying to solve a physics problem, okay, I give you a physics problem, which we're going to do right now, and you're like, okay, cool, I got this physics problem, I got 4 equations. Which equations do I use? You pick the one that's missing a variable that wasn't mentioned in the problem at all. Kind of makes it easy to think of it that way. So y'all get this written down. Make sure you have all 4 nice and neat on your paper that you're about to work on. Also, there's a fall, it's called fall equation sheet, but the whole semester is fall for you. But it's fall, it's just 1/2 of all the equations you're going to use this semester. And I recommend you also print those out and keep that handy too. But for right now, write these. And then let's do a couple problems. I like your editing. No, you should say, bring it on. Bring it on. Show me what you got, please. All right, here we go.
Wait.
Whoa, okay.
Oh, yeah.
Kevin, stop writing your left hand. I'm just kidding. That's it. It's got a picture. No, it's not. This is the, the Einstein sheet. You might want to also print that out. It could be helpful. It's up to you. The Einstein sheet is useful information, like some basic conversions that you may come across in a problem, like how many centimeters are in an inch? 2.5. You don't have to memorize this. 2.5.
Wait, what do you think?
How many slugs in a kilogram? How many pounds in a newton? Things like that. But that's not the equation sheet. That is useful.